Hello everyone. Welcome back to Dr. Lou's VCE Chemistry channel. Today, let's learn together about the 2021 VCE Chemistry examination. We will focus on questions related to equilibrium and rate of reaction. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. A is an exothermic reaction, but the decomposition of NO2 is an endothermic reaction. So, A is eliminated. B is the reverse reaction of number 2. Number 2 reaction is an exothermic reaction, so B should be an endothermic reaction, but it is an exothermic reaction, and B is eliminated. C is an endothermic reaction, which is the reverse reaction of number 3. Number 3 is exothermic. So, C is consistent with the number 3 reaction, and C is a correct answer. D is an exothermic reaction, but number 4 is an endothermic reaction. So, D is eliminated. When a catalyst is added to the reaction system, the energy of the reactants and products will remain at the same level, but activation energy will decrease. So, A is correct. Because the activation energy decreases, the shape of the energy profile will be changed. So, B is eliminated. The peak of the energy profile will be lower but not move to the left. So, C is eliminated. Yes, the activation energy of both forward and reverse reactions is lower, but the higher proportion of the forward reaction is that of the reverse reaction. So, D is eliminated. The picture shows that the rate of reverse reaction rapidly increases and the rate of forward reaction slowly increase. This phenomenon means that the amount of products increases. Only C is consistent with this phenomenon, so C is correct. If argon, an inertial gas, is added to the system, the concentration of reactants and products remains at the same level. So, A is eliminated. If reactants are removed from the system at time t1, the rate of reverse reaction would not increase. So, B is eliminated. The equilibrium constant is only influenced by temperature, not other facts. So, D is eliminated. A catalyst cannot change the position of equilibrium, so A is eliminated. Yes, the concentration of high at T3 is higher than that at T1, however, it does not mean that the amount of high at T3 is higher than that at T1, so B is eliminated. Since the concentration of I2 and H2 at T3 is higher than that at time T1, the rate of reaction producing high at T3 is higher than that at T1, and C is eliminated. Since 1 mole high produces 2 H2, the rate of production of high at time T3 is double the rate of production of H2. So, D is correct. One change altered the equilibrium constant at time T4. This phenomenon means that the temperature of the system is changed. When equilibrium was re-established at time T5, the rate of the reverse reaction at time T5 was higher than that at time T3. This phenomenon means that temperature increases because the increase in temperature induces an increase in the rate of reaction. Furthermore, this reaction is endothermic, so the increase in temperature induces an increase in the equilibrium constant. C and D are eliminated. The total chemical energy increases when the temperature increases because the endothermic forward reaction is favored. So, A is correct. We know that the initial mole of reactants and products can calculate the final mole of products and are asked to calculate the equilibrium constant. Changing the mole is key. The changing mole of the product is positive, and the changing mole of reactants is negative. The ratio of changing mole is equal to the ratio of coefficients of molecules. The mole of all reactants and products should be converted to molarity concentration. Finally, we combine all reactant concentrations and products into the equilibrium constant equation and calculate it. Please note that an equilibrium constant has units. When the temperature decreases, the average of kinetic energy decreases but the number of total particles isn't changed. So, the new peak will become higher than the original peak and shift to the left of the original peak. Describe the effect of the doubling volume on the concentration of SO2. As the volume doubles, the concentration of SO2 halves. As the system moves to re-establish equilibrium, the concentration of SO2 gradually increases because the greater number of particles is on the SO2 side. Once equilibrium is reached, the final concentration of SO2 is still lower than the original concentration, before volume increase. Although it was not explicitly required, some students included a concentration time graph that assisted them in communicating their understanding. 5 multiple-choice questions worth 5 marks, and 1 short answer question worth 9 marks in this section on equilibrium and rate of reaction. The overall score for this section is 14 marks. With a total possible score of 120 points, the percentage for this section was 11.7% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.